We live on a delicate speck of life adrift in a vast and unpredictable universe. Though it may feel secure beneath our blue skies and stable gravity, the cosmos has never promised us safety. In fact, the more we learn about the universe, the more we come to realize Earth's survival is anything but guaranteed. Forget the cliches of killer asteroids or alien invasions. The truth is far more unsettling and less cinematic. There exist forces in the universe that could end life on Earth in the blink of an eye, often without any warning. What follows are four of the most terrifying threats, each grounded in real science, that could erase our world tomorrow. One of them, when I first learned about it, kept me awake at night. This is not science fiction. This is reality. Deep within the dark canvas of space wander monsters unlike anything we can see with the naked eye, rogue black holes. These cosmic reapers roam the galaxy alone, unseen and almost undetectable. Not even Einstein believed they could truly exist. Yet today we estimate that up to 500 million of them may haunt just our own Milky Way galaxy, with untold trillions drifting across the wider universe. A rogue black hole forms when a massive star exhausts its fuel and collapses in on itself. What remains is a gravity well so dense not even light can escape. Without an orbiting companion to betray its presence, this black hole becomes invisible, a celestial assassin gliding through the void. So how do we even know they're there? Our best tools rely on indirect observation. Sometimes we catch them siphoning matter off nearby stars. Other times we detect their intense gravity slinging stars into bizarre orbits. But the most haunting method is through gravitational lensing, when a black hole bends light from stars behind it, warping our view like a cosmic funhouse mirror. These stellar mass black holes may contain the mass of our sun, but they're compressed into a sphere just 6 kilometers wide. For perspective, our sun spans over 1 million kilometers across. Detecting something that small, dark and fast-moving is a monumental challenge. The nearest known rogue black hole, Gaia BH1, lurks around 560 light-years from Earth. That might seem comfortably distant until you realize we've only discovered a few dozen. Statistically, there should be one within 50 light-years of us. And if one enters our solar system, the consequences would be catastrophic. There are 3 main doomsday scenarios. Direct collision. The black hole consumes Earth completely. Extremely rare, 1 in a billion, but instant. Tidal disruption. The black hole comes close enough that its gravity tears Earth apart, stretching it into a spaghetti-like strand of debris. 1 in 10 million odds. Orbital chaos. The black hole passes through the solar system, warping planetary orbits. Earth could be ejected into deep space or spiral into the sun. This is the most likely threat, with a 1 in 10,000 chance over the solar system's lifetime. If such a fate ever befalls us, there would be no warning and no escape. It's cosmic roulette, and we may already have our number. It's easy to forget that 50 million kilometers away, a nuclear inferno burns day and night our sun. A life-giving beacon, yes, but also a ticking time bomb. Roughly every 11 years, the sun enters a phase of heightened activity called the solar maximum, and we've just entered the next one. While the sun will one day expand into a red giant and engulf the Earth that's billions of years away. A more immediate danger lies in solar storms, massive eruptions of charged particles known as solar flares and coronal mass ejections, CMEs. These events launch billions of tons of solar plasma into space at blistering speeds. Most of the time, Earth's magnetic field shields us. But when a CME is aimed directly at our planet, the results can be devastating. The most famous case, the Carrington event of 1859. Astronomer Richard Carrington witnessed a blinding flash on the sun's surface. 18 hours later, auroras lit up skies worldwide, even near the equator. Telegraph systems burst into flames, and that was in the pre-electric age. A Carrington-level event today would cripple modern society. Power grids would fry, satellites would malfunction, planes could be rerouted mid-flight, and communication systems would collapse. The global internet could vanish in an instant. These storms occur because of the sun's tangled magnetic field. Superheated plasma loops snap, reconnect, and launch solar matter like slingshots into space, sometimes at over 9 million kilometers per hour. We'd have less than 24 hours to shut down critical infrastructure. If we fail, millions could die not from the blast itself, but from the collapse of power, water, and food supply chains. And here's the kicker: this is the least scary scenario on our list. The next existential threat wasn't discovered by accident, it was discovered because of an accident. In the 1960s, during the Cold War, U.S. satellites named Vela were launched to monitor nuclear tests by detecting gamma radiation. But instead of finding Soviet nukes, they picked up something stranger: bursts of gamma rays from space. By 1973, scientists had logged 16 such events but didn't understand them. Decades later, we uncovered the truth. These were gamma ray bursts, GRBs, the most energetic explosions since the Big Bang. Caused by either the collision of neutron stars or the collapse of massive stars into black holes, these bursts shoot narrow beams of radiation across space. If one points at Earth within 200 light-years, we're doomed. A GRB delivers more energy in 10 seconds than the sun will emit in its entire lifetime. It would incinerate Earth's ozone layer, flood the surface with lethal radiation, and trigger mass extinction. Sound extreme, it's happened before. Around 440 million years ago, 85% of Earth's species went extinct. Some researchers believe a GRB may have been the culprit, striking from over 6,000 light-years away. We can't predict them, we can't stop them, and we can't survive them. All we can do is hope the universe isn't aiming its cosmic sniper rifle in our direction. If everything else felt terrifying, this last scenario rewrites the rules of the universe itself. It's called false vacuum decay, and it could destroy not just Earth, but all existence as we know it. Let's break it down. Everything in the universe operates within fields, quantum fields that define the properties and interactions of particles. Among these is the Higgs field, which gives particles their mass. But there's a possibility that the Higgs field isn't in its most stable state. It might be in a false vacuum, resting in a temporary precarious valley of energy. If even one tiny region of this field tunnels into its true vacuum, a lower, more stable state, it would trigger a chain reaction. This vacuum bubble would expand at the speed of light, rewriting the laws of physics as it goes. Everything in its path, matter, energy, even time itself, would cease to exist. Instantly. There would be no warning. The Earth would vanish before we even noticed. The terrifying truth. The math says this could happen at any moment. It's the ultimate cosmic doomsday. And the only silver lining is that we'd never feel it. This is not meant to induce fear. It's a reminder. A reminder that our lives, our planet, our species are all precariously balanced atop forces we barely comprehend. And while these scenarios may sound improbable, they are not impossible. In a universe governed by chaos, perhaps the most courageous thing we can do is to keep living, keep exploring, and keep appreciating the fragile wonder of life. Because until the end arrives, whether in billions of years or in the blink of a cosmic eye, we are still here. And that matters. Let's not waste the gift.